In our last video, we talked about the examples or the steps in the process it takes to solve a matrix using row reduction. Today we're going to first look at how to do it with a 3x3 system, which is not going to be the easiest to do. This actually will take up to 12, 13, 14 steps. By the time you're done, you might be able to combine steps, do a little shorthand, and maybe get it down to even 6 or 7 steps to do this big, long process. So, the first step is always to try to get this lower left-hand guy to be equal to 0. Well, right now, the way you would do that, in terms of what we learned back in algebra, would be maybe to try to, well, if I multiply this entire row by -2, then I'd have a -2 here, and then the -2 and +2 would cancel each other out. That's the idea we're looking at. So what we're going to do is we're going to multiply row 2 by -2, and that's the notation I'll use. The first and third rows don't change, and my middle one has now just been multiplied by 2. What I'm going to do next here, now I can combine these guys. This is going to be our third operation that we had said before, where we can add 2 rows together. So I'm going to take row 2 plus row 3 and add it into row 3. So notice again, the first 2 guys haven't changed. Remember we said we don't change the last guy till the last minute. And now in the last row, we got -2 and 2 gives you 0. 2 and 3 gives you 5, -2 and 1 is -1, -4 and 0 gives me my -4 there. This is the first step. If we go back to our original rules here, these are the recommended steps that we said we would take. We want to first begin by eliminating the bottom left entry. What we want to try to do next is get everything else that is below that diagonal to equal 0. So, to do that, I need to first make this guy into a 0. So to do that, again, well, I'm going to have to combine with the top guy, the top row. To do that, this would need to become a +2. The only way I can do that is if I multiply that entire row by +2, and that's what I've done here. Rows 2 and 3 have not changed still, just row 1. Now, these guys are the same, just opposite signs. So I can add row 1 and row 2 and plug it into row 2. So that means row 1 still hasn't changed. Remember, we don't touch it till the end. Row 3 is still the same. Row 2 I've now combined. -2 and 2 gives me the 0. 4 and 2 gives you 6. -2 and -2 is -4. And 2 and -4 gives you that -2 that we wanted. Alright, so the only thing left under the diagonal for us to fix is this 5. I need to turn this 5 into a 0 somehow. And this is where it gets a little tricky in this case, because I'm going to have to combine with these 2 rows, just like I've done in algebra, back in the algebra days with systems. If you eliminate one variable from 2 equations, now you can just start over with these guys. So to do that, I need to find something that these guys will have in common. So the only way to do that is with a 6 and 5 turning into 30. So I'm going to do 2 steps actually at once. I'm going to turn this guy into a 30 by multiplying the entire row by 5. And then the second row, I'm going to turn into a 30 by turning it and multiplying by 6. Now, I'm going to make the bottom one a -6. That way I get a +30 along with a -30 here. That way I'll be able to eliminate these guys. My next step is to add these 2 rows together. That way these guys will eliminate. So when I do that, adding row 2 and row 3 together, plugging it into row 3, look what I end up getting. I have first row still the same, second row I haven't changed. Row 3 now will be 0 and 0 is still 0, 30 and -30 is 0, -20 and 6 is -14, -10 and +24 gives you a +14. Okay, this is now in row echelon form, so we're done with the second part because I have three pivot positions here going on. Everything under those pivot positions are all 0, so we're in good shape. My next step is to turn this bottommost pivot position into a 1. You don't have to do this immediately, but it's highly recommended. So I'm going to divide then that entire row by 14, -14 I should say. That way, when I do this, I will have a 0, 0, 1, and -1. So this is like saying z equals -1. I'm already partway done with my problem. Now at the same time here, I did a little extra step. I also saw that I can divide everything here in row 2 by the same number. If you can see that, go ahead and do it at any point, just to make the numbers a little bit smaller and they don't get too out of hand. So I'll have 3, -2, and -1 when I divide that second row there by 10. Okay, I've already given you the next step here. So what I'm going to do now is I need to try to eliminate for step 4 everything above this bottom pivot position. So I need to eliminate this -2 and then also this -2. So what I'm going to do here to do that is I'm going to make this in the bottom row a +2. That way I should be able to eliminate with both of those rows above it. So to do that, or when I do multiply by 2, that's what I get. So now I'm going to first eliminate right above it. I'm going to eliminate with row 2. So I'm going to add row 3 and row 2 together, and I'm going to plug it now into row 2 because that's where I want my 0 to show up. So when I do that, top row's the same, bottom row's the same, middle row now will be 0 and 0 is 0, 3 and 0 is still 3, -2 and 2 is 0 like we wanted, -1 and -2 gives you your -3 like you wanted. Now I'll do the same thing with the top row. So adding row 1 and row 3, and again, I want to make this my 0 above the pivot position, so that's what we'll be plugging into as row 1. So when I do that, I should get, excuse me, 2, 4, and now, because 2 and 0 is 2, 4 and 0 is 4, -2 and 2 becomes your 0, 2 and -2 here also becomes 0. Row 2 and row 3 stay the exact same. Now my next step, again, I could say at any time I can divide everything by the same number. I could even do it here with the last row. I just kind of wrote it in right there just to make myself a little note of it. I could have written out an entire new matrix if I wanted to. It's all about whatever way you want to do it, however concise you can make yourself have it. But the last thing I need to do, the only thing left that's not a 0, that's not on the diagonal pivot positions, is the 4. So to do that, I need to make this middle row be a -4. So I'm going to take it from this one spot, and I'm going to multiply that row by -4. So now I'll have 0, -4, or yeah, 0, -4, 0, +4, which is what I have over here. Now I can add row 1 and row 2 together. I'll plug it into row 1, so this becomes my 0, and I'll have, excuse me, everything else being 0. So row 1 and row 2 plugged into row 1. When I do that, 2 and 0 is 2, that's why the top entry is 2. 4 and -4 is 0, so there's my 0. 0 and 0 is still 0. 0 and 4 is 4, so that's how I have my entries right there. That is now in almost reduced row echelon form. We have only diagonals with numbers in it, everything else is a 0. Only thing left to do is make each of these entries 1. So I'm going to divide each of those rows by a number. I'm going to divide the top row by 2, that way I get 1, and this becomes a 2 in the end. I need to divide this guy by -4 by itself, so that it becomes a 1, and the bottom row by 2, so it becomes a 1. So my result in this on the side is 2, -1, -1. This is in reduced row echelon form, which is exactly what I want to have happen, because now I can just read off the answer, which is the last step. This is saying x plus 0y plus 0z. So 1x is equal to 2. Same here, 1y is equal to -1, and 1z is equal to -1. And that right there, ladies and gentlemen, is your final answer. Now, if this is your first time looking at a matrix like this, yes, it is very rough, insane, and lots are going on. Lots of stuff's happening here. They're not always this difficult, not even close to being this difficult, especially for your first look at it. So this is about as cumbersome as it gets, and like I said before, we can start learning to use little shortcuts, kind of like we did here in the yellow, to try to save us some steps, save us some room, combining a couple things into one. So don't panic too much, but this is where we are headed, and soon enough you'll be able to do one of these entirely on your own.